For this section, we're going to cover applications, which basically is story problems, but we're going to use systems of equations to solve them. When you did them before, it was kind of hard to figure out what to do to get everything in just one variable, but now that you can use two of them, it should make things quite a bit simpler for you. At least I hope. All right, for this first part, we're going to cover what is called direct translation. So we're going to take the words and translate them to operations and then make a system out of them, okay, and solve the system. So let's zoom in on the example side, and then you can do your side here in a sec. So the sum of two numbers is 76, and their difference is 26. Find the numbers. So first of all, we have two numbers. I'm going to call them, let's be different and call them A and B. Okay. Oh gosh, there that goes again. Okay, so A and B are my two numbers. Okay. So the sum of them is 76. So we're going to say A plus B is 76. And their difference is 26. So A minus B is 26. Find the numbers. So in other words, solve this system. And at this point, you can solve it any way you want. You could graph it if you wanted to, but I don't know why you would. Okay, I'm going to use linear combination because if I add it right now, the b's will cancel. Okay, so now I have 2a is equal to 102. Okay, divide by 2, and I get a is 51. Okay, so I've found one of the two numbers. Now, when we were solving systems, once you got the first one, you'd plug it back into either equation and find the second one. So you could do that, or you can use one of the two sentences or the two phrases, if you will. Sum of two numbers is 76. If one of them is 76, or try it again, one of them is 51, you have to subtract it and see what the other one needs to be. Okay, so the other needs to be 25 in order for these to add and give me 76, or subtract and give me 26. Okay, so it says find the numbers. There they are. Okay, now in Canvas, they may say the smallest and the largest, just so that you know you have to put the right number in the right box. But just get both of them for me and you'll be fine. Okay, go ahead and try yours. Let's see what you can do with it. All right, sum of two numbers is 64. If the larger number is 16 more than the other, what are the two numbers? Okay, so what I'm going to say is we have a large number and a small number. Okay, so I'm going to use L and S, large and small. Okay, so the sum of two numbers is 64. So L plus S is 64. Now it says the larger is 16 more than the other. Okay, now this is where before we'd have to make it work with one variable, but here we don't. Okay, so the larger one is 16 more than the other. That's it. Okay, so there's no reason to, oh, that's horrible. There's no reason to have to use one variable. Use both. That's the whole fun of it. Okay, now this one's set up specifically for substitution because I have L equals all by itself over here. Okay, so what I'm going to do is take this entire S plus 16, because it's equal to L, and put it in here, right? So I'm going to take all of this, put it in here for L. So I end up with S plus 16. Let's see, let's do it in the same colors. So S add 16 add S is 64. Okay, so L plus S is 64. Okay, combine like terms. And 2S add 16 equals 64. Okay, one thing I just thought of, please be really careful with your S's. Okay, if you make them obviously S's, you're okay. But if you do like a S and a 5, 5s and S's look kind of the same. Just be really careful that you don't get your S confused with a 5. This is a 2S, not a 25. And now we have a single equation with one variable. So we're solving it just like normal. And 48 right there. So divide by 2. I get S equals 24. Okay, and that's one number. Now we need to find the sum of two numbers is 64, and if one of them is 24, I'm going to do 64 minus 24. The other has to be 40. Okay, so L would be 40. And double check, these two do add up to be 64. And is the larger one 16 more than the smaller? Let's see, if I do 24, add 16, sure enough, I get 40. You probably already figured that out. Okay. And here's your second one, so a little bit lower on the page. The difference between two numbers is 43. The smaller number is 3 less than half of the larger. Find the two numbers. Okay, and I'm going to use S and L for small and large again. Okay, so the difference between the two of them is 43. Okay, so here's a question. Is this okay? The difference between the two of them is 43. And that's not quite right because I have the small one minus the large one like this. That would be a negative number. Okay, so large one has to come first, and then you're going to subtract the small one. Okay, so that's the difference between the two numbers. All right, the smaller one is 3 less than half of the larger. So 3 less than half of the larger. You could do 1/2 of, which is times the larger one, or you could do the larger one divided by 2. Either way, you're going to get the same answer because it means the same thing. Half of something means cut it in half, divide it by 2. Okay, since that's the one on the screen, that's the one I'm going to use. Okay, and again, this is set up to use substitution. However, there's a fraction in there. So I'm going to get rid of the fraction, and in the process of doing this, this won't be a plain S anymore. Okay, so I'm going to have to times everything here by 2. So this red equation now becomes 2S is equal to, these cancel, L minus 6. Okay, now I'm looking at the top one, the blue one, and the bottom one, they're not in the same order, are they? Okay, so I'm going to subtract L from both sides and put it in the same order as the one at the top. Okay, so I have L first, and then S is equal to -6. And now I'm going to write the blue one down here so I can have my two equations next to each other, or on top and below each other, whichever, so I can see what I need to do. And you can tell, I hope, that if you add them right now, the L's will cancel. So that's what I'm going to do. So add, L's cancel. This is a 1, so 2 minus 1 is 1, is equal to 37. And now that I know one of them, that's the smaller number, right? Now I need to put it into an equation with both variables. So it could be this one or this one or this one or this one or this one. Okay, I'm going to choose this one. So if I do L minus the 37 I just got, it's supposed to equal 43, right? Okay, let's give ourselves a little bit more space here. So I'm going to add 37 to both sides, and I get L equals 80. All right, so when it says find the two numbers and one's up here and one's down here, you've got a couple options. You could just say these are my answers, or you could totally rewrite it and say these are my answers. Don't put parentheses around it because it doesn't represent a point. It represents two numbers. Two numbers whose difference is 43. You subtract those and you do get 43. And the smaller one is 3 less than half of the larger. Half of the larger is 40. 3 less than that is 37. Okay, so either box or circle both of them or write both of them somewhere. Okay, this next type, they call it value applications. Basically, it's just money. Value is usually money. Okay, these look complicated, but they're actually quite easy when you know how to set them up. Okay, here we go. So admission prices of the local fair were $5 for children, $7 for adults. The total money collected was this amount, and that many people attended, how many children and how many adults attended. Okay, we've got all kinds of numbers representing all kinds of things. When you have a problem like this, specifically with tickets, so it's like tickets to the fair, your version is general seats and balcony seats. You could have matinee and evening movie seats, where you have two different things for two different prices. And you also have a total of money and a total of attendees. There's four different things that they don't really, how do you do this? Okay, you're going to come up with two equations using two variables, just like we've been doing with systems. So what two bits of information are we going to have be our variables? Okay, how many children and how many adults? Your answer is going to be the two variables that you set up. Okay, so I'm going to say children are C and adults are A. Okay, and actually I'm going to make them both the same color, and you'll see why here in a second. All right, now you need to come up with two equations using A and C. You have two types of information using both. You have price and you have total number of people who attended. Okay, so you have the amount of money collected and the number of people who attended. So you're going to have two equations. You're going to have one equation for money and you're going to have one equation for the number of people who attended. Okay, this one's the easier one, so let's start there. Okay, so we're going to start with A for adults and C for children. This represents the number of adults plus the number of children who attended is equal to 587. Okay, so this sentence is math sentence equation is about the number of people. Now I need a sentence or an equation connected to money. Actually, let's make this one the other color now. There we go. Okay, we know that adult tickets were $7, right? So right there. So every adult who came in paid $7. So if there were 10 adults, 7 times 10 is 70. Okay, if there were 100 adults, 7 times 100 is 700. 15, it would be whatever, you just figure it out. Okay, and to that, we're going to add $5 for each child who came. So $5 times each child. And that total was 3,379. And you have a system of equations. Okay, so that system is now what we're going to solve. This one is set for either substitution or linear combination because you have two variables without coefficients. Okay, I'm going to use a linear combination only because I like those better, but it doesn't matter. Okay, so I'm going to multiply this first row by -5. I choose the smaller of the numbers just so my numbers don't get huge. And let's rewrite it. I'm going to go up a little bit, make it a little smaller. Okay, here we go. So the blue equation becomes -5 times A and -5 times C, and -5 times 587 is -2,935. And then I'm going to leave my second equation, the red one, as is. And now I can add those because the C is going to cancel. Okay, so these are gone. I end up with 2A is equal to 444, I believe. I'm trusting that I didn't fat finger anything. Divide by 2, divide by 2, and A is 222. Okay, what did I find? A. What did A represent? Adults. How many adults attended? Okay, so I'm going to put adults down here just because it's part of my answer. And let's find the number of children now. Okay, you can put 222 into any equation with both variables. Okay, I would choose the first blue one because it's the easiest. However, you also know that the combination of two of them equals the 587. And if you know that there were this many adults, all you have to do is subtract 222 and we get 365 children. Okay, we know they add up to equal the 787 because I just did the subtraction. So double checking the red part, will be the way that we know if we did it right without blowing it on the calculator, right? And I just did all of the math, and I did get 3,379, which is what we started with. Okay, so it worked. Do you need to check it? No. Would it be helpful? Absolutely. Last thing I'm going to do is box the answers so that I can find it easier and see what you can do on yours. You've got two of them. Here's A and there's B on another screen for me. Okay, I'm going to use G for general and B for balcony. Okay, and again, I'm given two types of information. I am given dollars and I'm given numbers. So I'm going to have one equation for each of those. Okay, so dollars, numbers. Okay, the numbers are usually easiest. So I'm going to just add the total number of general admission tickets and the total number of balcony tickets and find my total in the paragraph. So 434 total tickets sold. Now the money version, you figure out how much was charged for each individual type. So general and balcony. Okay, general seats sold for $42.50. So I have 42.50 times G plus balcony seats were 37.50. So 37.50 times the number of balcony seats sold, and the total is $16,890. Okay, that's kind of a crazy looking system, but we have a system. Okay, so everything that you know how to do, you can now put into place. You can solve the first equation for G, substitute it in here. You could solve it for B and substitute it in here. You could multiply the red equation by negative 45 or 4250, so it'll cancel, or you could times it by negative 3750, so it would cancel. Okay, that last one is what I'm going to do because it's the smallest number. So negative 3750 times the entire thing, right? Like this. And let's get a new equation. So we have negative, actually, let's move it over a little bit more. Negative 3750 G minus 3750 B equals negative 16,275. Okay, and I'm just going to rewrite the blue one right underneath it. And let's see what happens. Okay, so I'm going to add these two up, and those cancel. So I end up with 5.00 if you want, but you don't need the 0.00. So 5G is equal to 615, which is going to work nicely because it's divisible by 5, right? So G then is equal to 123. So what did I find? G. What did G represent? the general seats sold. Okay, so the tickets for the general admission seats. So 123 general admission. They just called it general seats, so that's what I'm going to call it. And how do I get the number of balcony seats? We know that the total is 434. So I'm going to start with the 434 and subtract the 123. And we had 311 balcony seats sold. Okay, those two automatically add up to be the 434. And you could do the math to figure out if that's the correct answer for the amount of money sold. Okay, there we are. And if you haven't already tried this one, go ahead and try it and come back. So a small town movie theater sells matinee tickets for this much and evening tickets for this much. One day, a theater sold 212 tickets for the entire day and collected that much. How much type of each ticket did they sell? Okay, so we have matinee, whoops, yeah, that's better. Matinee tickets. Okay, I'm going to organize this just a little bit differently so you can see it. And evening tickets. Okay, so I'm going to say matinee tickets is M and evening tickets is E. Okay, so it doesn't matter how you set it up. You just need to stay organized. Okay, so like I said, I'm going to do it a little bit differently this time so you can see it. All right, so we know that there were 212 tickets sold. So I'm going to do matinee tickets plus evening tickets is going to equal the 212. And this is my equation about money. No, it's not. It's my equation about numbers. Now my equation about money, there we go, is going to be 750 for matinee. So 750 for matinee plus $10. Whoops, sorry about that. Times the number of evening tickets. And that is equal to 1,925. All right, just one little comment. You don't need this zero and you don't need those two zeros. I just like putting them in because it's money. I'm not going to continue with them though. Okay, so let's see, this one is set up. I'm going to times the top row by negative 10. It's not the smallest number, but it's the nicest number, if that makes any sense. Timesing by negative 7.5, it would work, but timesing by negative 10, I like that a lot easier because I can do it in my head, right? Okay, so the new number is going to be 10, whoops, negative 10m minus 10e is equal to negative 2120. And my new dollars equation, once I've dropped the zeros I don't need, 7.5m add 10e is 1925. Okay, so the 10e's are going to cancel, right? And we end up with negative 2.5 Whoops, I need to do that. Yeah, I don't need to do that in green. Hang on. Okay, so negative 2.5 m is equal to, yeah, it's equal to negative 195. Now we're going to divide by negative 2.5 on both sides. Coefficients cancel, and I get m equals 78. Okay, so what did I just find? M. What did M represent? Matinee tickets. Okay, so that's what I'm going to write. Matinee tickets. And E is going to be how many are left from the 212 after I sold those 78. And that ends up as 134 evening tickets. So I like to use letters that represent what I'm trying to find so that when I'm done, I don't have to think too much. If I had used X and Y, I'd really have to look back here and see which one was which. But if I put it as M and E, matinee, evening, this is easy, right? Okay, hopefully you did okay on both of those. New type of problem. Okay, still using money, so it's still in this section. We have a bank account at 5%, one at 12%. We put in money into two accounts, split up, and earn interest from it. Same thing here. Money into both accounts, split up, and you earn interest on it. Here's your 2%. Okay, so this is how we're going to set this one up. So we have two bank accounts, but we still have two items of information that we're looking for. Okay, so let's see. I'm going to write it like this. So the money, the money in the 5% account, we'll give it a variable here in a minute, and the amount of money, sorry, in the 12% account. Okay, you could use F for 5 and T for 12 if you want. You could use X and Y, A and B, doesn't matter. But I am going to use 5 and 12. Okay, T's. Be really careful that you don't make your T like a plus sign. Okay, so you might want to do a capital T. You might want to use an X and a Y. Okay, so here are my two equations. One of them is going to be the amount invested, so the money invested, and the other one is going to be what's connected with this one, interest. So interest earned money. So they're both money this time, which is kind of hard. Okay, so invested and interest. We know that the amount of money invested is going to be the money that we put in here plus the money we put in here. So F plus T is equal to the 8,900. Now, the money in the F account, you earn 5%. So you're going to earn 5% of F times, right? That's what of means. Add 12% in the T account, and you earn $753 in interest. Okay, so there is your system. Okay, you could do the decimal trick if you'd like and get rid of the decimals here and here, but that would add a couple extra zeros over here. Just be careful. You have calculators, so I'm just going to go ahead and times the top one by a decimal. And I'm going to choose negative 0.05. Okay, so my new first equation, now it becomes negative 0.05f. And actually, let me move that over so it lines up better. Okay, minus 0.0, no, it's not. Yeah, it is. 5t is equal to this times this times this. I just did those two. Now I'm going to do this one, right? So I'm going to do 8,900 times negative 0.05, and that's negative 445. That's my new first equation. So my second equation is going to stay as is. And there's my new system. So now this, I'm going to add it up so that the f terms cancel. So now I get 0.07 times t is equal to 308. I'm going to shrink it down a little bit. Divide by 0.07. Is that 0 in the front necessary? No, it isn't. I just like it because I don't drop my decimal off as easily that way. Okay, so these cancel and I get t equals 4,400. And I did that multiple times, so I hope it's right. Okay, I found t is this. T represented the amount of money in the 12% bank account. Okay, so that is money in, or I'm going to say at 12%. Okay, to get the amount at 5%, we know the total amount of money that we put in was 8,900, and now we've already used 4,400, so we have 4,500 left for the other account. Okay, there you go. Okay, so go ahead and try yours. Okay, this one's not as easy to find variables for, at least in my opinion. We have 6%, so I could use an S, and 8.5%, which I could use an E. I'm just going to use X and Y. S and E would be totally fine. If you did that, don't change it, okay? All right, so now we have two equations. One of them is, just like we had before, the amount invested, which was the 6,000. So I know that the amount of money I put in one account plus the amount of money I put in another account totaled $6,000. And now the interest that I earned is going to be 6% for the X account and 8.5% for the Y account. And I ended up earning $472.50. And there's my system. And again, it's set up to do either substitution, solve for either X or Y in the top one, or linear combination. And I'm doing linear combination most because, well, first of all, it's my favorite, but secondly, that's what we learned in this day today in class. Okay, so I'm going to times by negative 0.06 because I want positive 0.06x to cancel with this one. Okay, so I get negative 0.06x minus 0.06y. So I just did these two. Now I need that one, and I get negative 360. Bring the other, or the second equation down. X plus, and I'm not changing a thing on this second one, is equal to 472.50. If you want to put a .00 up there so it matches, do it. It's totally fine. Add, which means, oh, I didn't write it right, did I? Yeah, should cancel, and it can't because that should have been a 6 right there. Okay, so now we get 0.025y is equal to 112.5. If you want to just leave it 0.5 because that's what your calculator told you, that's great. If you want to put a 0 in because you know it's money, that's fine too. Doesn't matter. Divide by the coefficient of the variable, so that is 0.025, and we end up with 4,500. Okay, so we found y. What was y? The amount of money in the 8.5% account. So dollars at 4.5%. And we know the total amount of money was 6,000. So now I'm going to subtract 4,500 from 6,000, and I get 1,500. So X is $1,500 at the other account was 8. What am I doing? 4.5? Where did that come from? You guys are probably just rolling your eyes at me. Okay, Y is 8.5%, right? And X is 6%. So there we go. All right, another type of problem is mixture problems. You can see by looking at these two examples, we have almonds and sunflower seeds. Here we have candy and nuts. Anything that you're creating that uses two ingredients, basically. Okay, so let's take a look at the example. All right, here we go. Store sells a mixture of almonds and sunflower seeds. So A and S is what I'm going to use. The store wants to make 25 pounds of the mixture and sell it for $5 a pound. The almonds cost $8 a pound and the sunflower seeds cost $3 a pound. How many pounds of almonds and how many pounds of sunflower seeds should the store use? Okay, and because it's asking right here how many pounds of each, okay, I knew that's what my answer needed to include was how many pounds of each. So A is how many pounds of almonds and S is how many pounds of sunflower seeds. Okay, so it's like you write a key. You want to tell yourself and you want to tell whoever's reading it what you're doing so that can make sense. All right, so now we have to come up with our two different equations. Okay, so the store wants to make 25 pounds of mixture. So that means we're going to take the number of almonds, or the number of pounds of almonds plus the number of pounds of sunflower seeds totals 25 pounds. Okay, so that's the easy one, like I've said. Okay, so now almonds cost $8 a pound. So $8 times number of pounds of almonds plus sunflower seeds cost $3 a pound. 3 times S is equal to. Okay, now this isn't like the ticket prices where you have a total. Okay, what you're going to use is, let's find it up here. Yeah, I'm going to do it in a different color. Okay, we want to sell it for $5 a pound, and we want to sell all of it. Okay, the 25 pounds. Okay, so it's going to be $5 a pound for 25 pounds. How's that for weird? Okay, so let me simplify it. Tell you what. So if it sells for $5 a pound and you had 25 pounds, it's going to be $125. Okay, and that's going to go right here. Okay, and there's our system. All right, now let's see. I'm going to times the top equation by -3. Okay, so the top equation becomes -3a minus 3s equals -75. Okay, now because it's lined up right there, could you use this new red equation with the blue equation and cancel these here? Sure you could. However, it's not a complete system the second time until you write it the second time. If you're skipping steps like that, just make certain you're organized enough that if you get distracted, you can come back and see exactly what you did. And if I'm correcting it, which I will be, I can also see what you did. Okay? If you're jumping around too much, I may not know where you're going. Okay, let's shrink it down a little bit so I have room to finish this one. All right, so here we go. Adding these, those cancel. So I get 5a is equal to 50. Divide by 5. So I get A is 10. What did I just find? A. What did A represent? Pounds of almonds. Okay, so there you go. 10 pounds of almonds. Okay, how do I find the amount of sunflower seeds needed? You know that it's going to be 25 pounds, right? So 25 minus the 10 is 15. So 15 pounds of sunflower seeds. That's a long label. And let's say you wanted to check this one, okay? You already know the red one. A plus S is 25 because that's what I used here. So all you would have to check is the blue one. So I'm just going to sneak it in there. So I'm going to go 8 times 10 plus 3 times 15. Okay, so I have 80 and 45. Add those up, and I do get 125, so it checked. Again, is that necessary? No. Is it helpful? Absolutely. Okay, you have an A and a B. Okay, so here's your A version. Let's see how you do. Okay, make certain you're actually stopping the video and trying it on your own. Okay, and now I wish this were a real problem. Yeah, check this out. $1.80 a pound for nuts. Yeah, that doesn't happen anymore. Okay, so we're going to do that for my key. So now let's come up with the two equations. Okay, they want to combine candy that cost $1.80 a pound and nuts that cost $1.20 a pound, and they need 20 pounds. Okay, so candy plus nuts is going to equal 20 pounds. Okay, candy is $1.80 a pound. So $1.80, and again, I'm just going to put the zero because I know it's money, and $1.20 per pound for the nuts. So 120 N. And they want it to be 20 pounds at $1.56 per pound. Okay, so you would just multiply those two to get your answer. So if they were to sell all 20 pounds, it would make them $31.20. Okay, that goes down here. And there's my system. Okay, I'm going to times the top equation by negative 120. So we end up with negative 120C minus 120N is equal to negative 24. Calculator just left it like that, but I know it's money, so I'm going to add the dollars just to keep myself sane. Okay, second equation is 180C plus 120N is equal to 3120. And add these up. Middle term cancels. So I end up with 60 cents times C is equal to $7.20. Okay, divide by 60 cents on both sides. And I end up with C equals 12. Okay, got C all by itself. C represented the number of pounds of candy. So this is 12 pounds of candy. And how do I find out how many nuts? We know that the two of them added together have to be 20 pounds. Okay, so what do you add to 12 to get 20? It's going to be 8. Okay, and there you have it. Okay, let's look at your next one. Okay, this problem, I don't know if you tried it and if you got it to work or not, but let's take a look at it. We have lots of numbers, and let me make sense out of it for you. Okay, so we have a 20% solution and an 80% solution. And we're going to pour some of each of these into another container with the right proportions so that we end up with 15 liters of 40%. Okay, so the 40% is between the two, right? So I'm going to have some of each so that it can meet somewhere in the middle. Okay, I'm going to call this one X and this one Y. So that gives us one equation. We know that we're going to pour sum of the x and sum of the y together, and we're going to get 15 liters out of it. Okay, then we know that we want 20% solution for all of the x amount that we use, the liters of x, and 80% solution for all of the y liters that we use. And we want the answer or the result to be 40% of the total amount, which is 15. See, so this is very similar to the seeds and nuts and candy type problems, right? It's just here you have percents instead of money. This is our system. And now we have to simplify it a little bit and see what we can do, okay? I'm going to give us a little bit more room to work here. So first of all, right here, I need to simplify that, right? So I'm going to rewrite, actually, let's just do the one because I'm going to have to rewrite it here in a second anyway. So this is equal to 6 when you multiply. Okay, so across the top equation, I'm going to multiply it by negative 0.20 or 0.2. So that way I can cancel the x's out. So the new first equation becomes negative 0.2x minus 0.2y is equal to negative 3. Second equation, I'm going to write right below it, and I'm going to drop off the zeros at the end so it matches. Add 0.8y, and that's equal to 6. Okay, there we go. Adding those up, these cancel. So I get 0.6y equals 3. Divide both sides by, just do it in black, 0.6, 0.6, and I get y is equal to 5. So I found y, and y represents the 80% solution. So I need 5 liters of the 80% solution. Okay, and we know that together they have to add up to 15, right? So I'm going to do 15 minus the 5, it's obviously 10. Okay, so x is going to be 10 liters of the 20% solution. There we go. So if I mix these two, then I will get the 40%. Okay, the last type of problem is distance, rate, and time. The formula is really easy, so distance equals rate times time. But this tends to get a little bit more complicated. Okay, it's not hard, just complicated. So let me explain it so it won't be so bad for you. Okay, so a plane flies 720 miles with a tailwind, in other words, pushing from behind, in 3 hours. The return trip takes 4 hours going against the wind. So what is the speed of the plane in still air and the speed of the wind? Okay, so let's see what we've got. So I'm going to draw it out just a little bit for you. Okay, so here is the 720 miles. Okay, all right, we have a plane going with the tailwind in 3 hours. So here's the plane going the whole 720 miles with a tailwind. Okay, so it's being pushed. So this is the wind, and this was the plane. Okay, the return trip, so we're going back again. You can see we're going against the wind. Okay, and that took 4 hours. Oh, yeah, it took longer. So you need two equations with two variables. Okay, so we're going to use distance equals rate times time. And we're going to do one equation for going to our destination and one equation for returning from the destination. Okay, so here we go. The distance is 720 miles, and that's equal to the rate times the time. Okay, the rate in this case is going to be the plane being pushed by the wind. Okay, so this is going to be a rate of the plane pushed by, so we're adding it onto the wind. And it took 3 hours. That's the time. Okay, the return trip, same mileage, 720 miles, but this time it took 4 hours and the wind is blowing this way and the plane is going this way. So we're going to slow down, right? So we have the plane minus the wind. Those are our two equations. Okay, so now we're going to distribute here and here. And I'm going to rewrite it over on this side so that I have extra space to work if I need it. So that gives me the first equation of 720 is equal to 3 times P plus 3 times W. The second one, 720 is equal to 4 times P minus 4 times W. And that is our system. Okay, because I have two different signs here, I am going to eliminate the W first. So I'm going to times the top one by 4 and the bottom one by 3. That way I get a positive 12 here and a negative 12 here. And then the W will cancel. Okay, so what do I have? I have some pretty big numbers. Okay, 720 times 4 is 2,880. And that's equal to 12P plus 12W. The second one is going to be 720 times 3, which is 2160. And then 3 times both of those gives me 12P minus 12W. And add those up so the W's cancel. And we get 5040 is equal to 24P. Divide by 24. And I get 210. Okay, what did I just find? P. What did P represent? The plane. Okay, specifically the speed of the plane in still air. Okay, without a wind. That's what it's asking. So without the red part, I just need the blue part. Okay, so the plane, um, I'm trying to figure out where to write the answer. I'll do that here in just a second. Okay, let me now go back, plug in P into one of the equations with one of the variables, or with both of the variables, and solve for W. Okay, so we have this one that has both, this one that has both of these with the huge numbers, which I'm not even going to try, or I have the original. Because I've already distributed and I got this, I'm going to use one of these two. Okay, since I will be substituting it in for P, these two look pretty much the same, but I'm dividing by the coefficient of W, so I'm going to use the top one instead of the bottom one because then I have a negative to deal with. That's just where my brain goes. Okay, so I'm going to put it into the top one here. 720 is equal to 3 times 210, add 3W. So 720 equals 630, add 3W, minus 630, and I get 90 is equal to 3W, divide by 3, and I get W equals 30. Okay, double check that those answers make sense. Okay, so the plane at 210 miles an hour, is that legit? Okay, I didn't know for certain, so I looked it up. Passenger planes usually go around 500-ish miles per hour. So that's not going to be a passenger plane. It'll be smaller, but yeah, it seems like it's going to be okay. Okay, so the plane is 210 miles per hour. And I also looked up the wind. Whoops. See if I can do this without hitting the wrong button. Wind was 30 miles an hour. Uh, Wind speed is about 20 miles an hour in a pretty bad storm. So that's it's getting a little iffy, right? Okay. But still, it makes sense that the wind is much, much, much um, slower than the plane, and the plane is much faster than a car. So it works. They have to work on the numbers a little bit better, but it works. Okay, but the idea is you have two equations, one for traveling one direction and one for traveling back, and you take the wind into consideration on both of those. Okay, so go ahead and try yours. This one is talking about a motorboat going up and downstream. Okay, so the speed of the current is replacing the speed of the wind. Okay, all right, go ahead and try. Okay, so I've drawn part of it out so far. So here's your boat going upstream, and here is the same distance your boat going downstream. Now it's talking about the current. Okay, if you're going upstream, the current is pushing against you. Okay, so this is going to be the current. And if you're going downstream, the current is working with gravity and it's going down, right? Okay, now let's set up our equations. So this distance from here to here is 24 miles. And we know that, where are the times? Right here and here, right? Okay, so distance equals rate times time is what we're starting with. Okay, so the distance, this is the upstream one, is 24. the rate is going to be, say, B for boat, and you're going to subtract the current. Times it by the time. Now let's go back up and figure out which one it was. Trip upstream against the current takes 3 hours. Okay, so 3 right there. Now, downstream with the current, so we're going to add a little bit of a push because we're going downhill and the current's pushing the boat along. It's going to only take 2 hours. Find the speed of the motorboat, so B, in still water, and the speed of the current, C. Okay, let me do the same thing as what I did last time and bring this over here to start so I have extra space to work forward on my page. Okay, so upstream becomes 24 is equal to 3B minus 3C. Downstream becomes 24 equals 2B add 2C. There's our system. Okay, and again, I'm going to use this part. I'm going to eliminate C because the signs are already opposite. But I'm going to have to times it by a 2 on the top and a 3 on the bottom in order to get a 6 on both of those, one positive, one negative. So we end up with 48 is equal to, whoops, not 3B anymore, 6B minus 6C. And on the bottom, we get 72 is equal to 6B plus 6C. Add those up right now because the C's canceled, and that's what we wanted, right? Okay, let's give us a little bit more space. Actually, we don't need to see the your turn. We're fine. Okay, so we end up with 120 is equal to 12B. Divide by 12. So B is equal to 10. So that means the speed of the boat is 10 miles an hour. Okay, let's check and see what the current is going to be now. So I need to substitute this into an equation with both variables. You have a whole bunch. I'm solving for C. I already know B. So I'm going to choose the bottom equation because I'm dividing by the coefficient of C, which is positive. Okay, so I'm going to put it in here. 24 is equal to 2 times B, which is 10, add 2 times C. So 24 is equal to 20 plus 2C minus 20 from both sides, and I get 4 equals 2C. Divide both sides by 2, and seems to have worked quite well, where the current is much slower than the speed of the boat. If you got it backwards and the current was faster than the boat, there's probably a problem. Okay, so let's make certain you write the answers completely out. Okay, so the boat, you could write motorboat if you want to, but boat is fine. The boat is 10 miles per hour. You could do mph. And the current is 2 miles per hour. And there you go. Okay, hopefully you got that one. See, every single part of this we've done before. You've done distributing, you've done combining like terms, or multiplying to get the coefficients to cancel. You've done all of this. So just take it one step at a time and you'll be fine. Okay, last problem. This one, the red part is important to understanding this, okay? So let me draw what we have again. Okay, but this time we don't have a distance. We have the boat going upstream. Let's see, let me change this. Okay, so the boat is going upstream, which means the current is pushing against it, right? So here's the current, and this is up. It's the boat. Okay, 3 miles an hour. Averages 3 miles an hour. That's the boat. Returning downstream, it averages 7 miles an hour. But it doesn't say how far it's going. It says it averages, which means downstream is faster, upstream is slower, but we don't have a distance. Okay, so this is downstream, and it's the boat. Okay, so that's the exact picture that I did last time, but there's a problem with it. Okay, so this means 3 miles per hour means the boat traveled 3 miles in 1 hour. Okay, so this arrow represents 3 miles per hour. So that means this arrow, whoops, sorry, my alarm keeps going off. Here's 1, here's 2, here's 3 in an hour. Okay, so that means that this bottom arrow here is actually bigger because it needs to be 7. Okay, 7 miles in 1 hour. So that means da, 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 1, 2, 3, 4, 5, 6, 7 in 1 hour. Okay, that's not the important part. That's just to help you make sense out of it. Okay, distance equals rate times time. So when I'm filling this in for upstream and downstream, what do I put for the distance? Okay, that's equal to, going upstream is going to be the rate of the boat minus the rate of the current times the time. Do I have a time? Okay, going down, we don't know a distance, but we do know that it's the boat with the current, and we don't have a time. Okay, we do. You just need to know where to find it. Okay, so if this one is upstream, it's 3 miles per hour. In other words, 3 miles in 1 hour. This is our distance and this is our time. Okay, so let's put them in over here. We're going to do distance is 3 in 1 hour. Okay, so downstream, that is 7 miles per hour, which means 7 miles in 1 hour. Okay, so the distance is 7 and 1 hour. Okay, that made this one a lot easier once we get it set up, because if I distribute a 1 to both of these, it doesn't change anything, right? Okay, so our two equations become 3 is equal to b minus c, and 7 is equal to b plus c. And we can add them right now. C's cancel. I get 10 is equal to 2b. Divide by 2, so b is 5. Substitute it into either equation that you would like. I'm going to choose the second one. So 7 is equal to 5 add c. So if you can do it in your head, that's fine. But here's the algebraic work. We get 2 equals c. So that means the boat is 5 miles per hour and the current is 2 miles per hour. Okay. All right. I can almost guarantee you that you'll have one of this last type of problem. I've seen that on every exam for quite a long time. Okay. So you need to know how to deal with the current or with the wind speed and the speed of a boat or the speed of a plane or the speed of whatever it is. Okay. So make certain you understand how to do this type of problem and you're good to go. Okay, bring questions to class and good luck on your homework that you have.